Okay, so chapter 6, section 3, we're going to show that a quadrilateral is a parallelogram. So it's not page 516, so we can just ignore this. So our first theorem states that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is congruent. I know. I just had to read it before I write. So both pairs of opposite sides of a quadrilateral are congruent. Then the quadrilateral is a parallelogram. So if we know that both pairs of opposite sides, opposite meaning opposite sides, if we know that those are congruent, then we know that it's a parallelogram. So everything else that we know about parallelograms is true too. So if we know for a fact that both pairs of opposite sides are congruent, now we know that opposite angles are congruent.
I'm not. Can you please leave? I don't think. Yeah, you see the problem.
We know that the opposite sides are also parallel. So we know all the other facts about parallelograms just if we know that both pairs of opposite sides are congruent. Our theorem states that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if we know that both pairs of opposite angles of a quadrilateral are congruent, then we know that it's a parallelogram, and we know all the other facts about parallelograms hold true in this too. If we have one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So now we only need one pair, but it has to be both congruent and parallel. Okay, next, if the diagonals of a quadrilateral bisect, then the quadrilateral is a parallelogram. So if the diagonals bisect, then the quadrilateral is a parallelogram. What does bisect mean? Cut in half. So we have 5 ways to prove that a quadrilateral is a parallelogram. If we show that both pairs of opposite sides are parallel, if we show that both pairs of opposite sides are congruent, if we show one pair of sides are both parallel and congruent, and if we show both pairs of opposite angles are congruent and the diagonals bisect each other. So if we know that one of these are true, then we know that our quadrilateral is a parallelogram. And this just restates our 5 ways again, and it has little pictures for each one. So we know that when it has the little arrows on the side, that's talking about the sides being parallel. If it has the tick marks, we know that that means it's congruent. If it has the arc marks, then it's talking about the angles being congruent. If it has both a tick mark and an arrow, it is both congruent and parallel. And then bisect cuts it in half, so we know that we have 2 pairs of congruent diagonals. So example 1, state the principal definition or theorem that enables you to deduce from the given information that the quadrilateral is a parallelogram. So first we have BE is congruent to ED. So we can say this is congruent to this, and CE is congruent to EA. So we know that these 2 parts are going to be congruent also. Can we tell that this is a parallelogram just by the information given in number 1? Yes. Because the diagonals are bisecting each other, which that was one of our rules. So yes, this is a parallelogram. Let's look at number 2. If angle ABD, or BAD, this angle, is congruent to angle DCB, this one, and angle ADC is congruent to angle CBA, can we say that this is a parallelogram? Yes, because we have opposite angles that are congruent. We have 2 pairs of opposite congruent angles. So yes, this is a parallelogram. Next, we have BC is parallel to AD. And AB is parallel to DC. Can we say that it's a parallelogram just by knowing this? Yes. Why? How do we know that this is a parallelogram for number 3? Because opposite sides are parallel. Perfect. Let's look at number 4. We have BC is equal to AD, and AB is equal to DC. Just by knowing this, is this a parallelogram? Yes. Why do we know that? Because both pairs of opposite sides are congruent. Perfect. And then last one, we know BC is parallel to AD, and BC is congruent to AD. Just by knowing this, is this a parallelogram? Yes, because we have one pair that is both parallel and congruent. So yes, it's a parallelogram. Ready for the next example? Show that ABCD is a parallelogram for x is equal to 7 and y is equal to 4. So what do you think we need to do first here? We plug it in. It gave us x is equal to 7 and y is equal to 4, so let's plug those in. So we have x is 7, so now we have 7 plus 14. So what is side BC?
21.
And then here we have 3 times 7, so what side AD?
21.
And then y, it told us it was 4, so we have 2 times 4 plus 8. What side CD going to be?
16.
And then we have 5 times 4 minus 4. And what's AB? 16. So we know AB is congruent to CD and BC is congruent to AD. So can we say that ABCD is a parallelogram? Yes. And why can we say yes? Because both pairs of opposite sides are congruent. So we know that it's a parallelogram. Ready for the next one? Determine if each quadrilateral must be a parallelogram. Justify your answer. So let's look at A. Does this have to be a parallelogram? No. Why no?
Both sides are
Right, because we don't have both pairs of opposite sides are congruent, or we don't have both pairs of opposite sides are parallel. So, no, this is not a parallelogram. Now let's look at B. Does this have to be a parallelogram? Yes. Why? Because the diagonals are being bisected. Perfect. Any questions on these two? All right, last page. Determine if each quadrilateral must be a parallelogram. Justify your answer. So 2A.
Yes.
How do you know?
Because both pairs of opposite angles are congruent.
How do you know that the opposite angles are congruent? We know that these are congruent, but we don't know if these two are congruent.
Transversal.
But we don't know if they're parallel. What? Well, we would need to know that this is congruent to this. Is there anything that we've learned in the past that tells us that those two are congruent?
The line that's like cutting them between is congruent, right? So it's like angle, side angle.
The angle bisecting.
That's a good, so we know that this is congruent, right, to itself. So we have angle, angle, side, right? Angle, angle, side. So we know that these two triangles are congruent. So does that tell us that this is congruent to this?
Yeah, because if the triangles are congruent, then everything's the same, right?
Yeah. So we know that this is congruent to this. So now if we add these two together, it gives us the same thing as these two. So now do we have our opposite angles are congruent? Yes. So is this a parallelogram? Yes. Another theorem that tells us that this is congruent to this is the third angle theorem. Since we have these two sides of the triangle are congruent to these two sides, then the third angles must be congruent. So that was a good job, Massimo. All right, let's look at B. Do we know if this is a parallelogram? No. Why not?
Because the opposite sides are not parallel.
Right, because these are not opposite sides. Those are consecutive sides that are congruent. So no, it's not a parallelogram. Alright, so this was 6.3.